All right, so what we're doing now is walking down one of the external corridors in Broida. We have a dilution refrigerator, which I'll explain later, but it's an expensive piece of equipment whose job is to cool things to near absolute zero. And this lab is where it lives. Now, this lab needs to be cleaned out for a new faculty member to come in. So me and Hugh are going to try to get this dilution refrigerator, which hasn't been fired up since about 2016, working. This is going to be a challenge because there's going to be a lot of things broken. This is a $500,000 piece of equipment that's just sat and rotted. So we'll see how it goes. Let's get in there and see how it's going. We got this machine over here. So this is a dilution refrigerator. It uses a pulse tube cooler, which you can see in here somewhere, which cools it down to 4 Kelvin and then uses the science equivalent of a swamp cooler, except instead of water, we use helium-3 and helium-4 to cool things down to about 20 millikelvin. So this thing has just been sitting here. It's huge and expensive. Even worse, it's got a fully manual gas handling system over here, which we'll talk about later. But we're going to try to get this thing working. So we're going to clean it up, we're going to close up the system, and we're going to see how it goes. This is where we got to get inside the fridge. So what we got to do, our first order of business is to take out some of this loose wiring on the mixing chamber, and then we got to clean this up. Just isopropyl alcohol and Kim wipes should do it. All right, first step, we got to get all these cables off. They're loose. They use these nutty microwave connectors that only the Google guys use. So we're going to take these off. This whole thing is at about 20 millikelvin. And you don't want to have loose things hanging around because, say for this piece here, say there's a loose screw here that's not, say it's not anchored to anything, this is going to stay at 300 Kelvin because it has very poor thermal conductivity here. So you're just going to have these hot things that are going to slowly heat down these wires, and they're just going to warm up your mixing chamber. So you're never actually going to get cold. So what we're going to do is take off all this loose wiring. We're going to then clean all this off with IPA and acetone. Get in. There's a bunch of loose screws and stuff that we don't need here. We'll make sure everything's clean and looks good, and everything is. There's nothing that's just kind of hanging in crummy thermal contact. Then we'll go through here and close it up, see if it holds vacuum. That'll be step one. Hugh is a physics professor here too. He does dark matter. He leads a big program for this thing called Lux, or LZ. It's LZ, right?
Yeah, it's LZ.
It's
Well,
LZ.
it's Lux Zeppelin, which is itself an acronym, but we just call it LZ.
So LZ is a big liquid xenon detector for doing dark matter searches. It's found what it expected to find, which is very exciting. And what we're gonna do is we're gonna look at this fridge and see if we can repurpose it for use as a dark matter experiment. Not a large liquid noble gas experiment, but some of these more sensitive techniques that are aimed at lower mass dark matter. So first step, get it working. If we can get it working in this room, then we'll move it to Hugh's lab, where we'll try to get some money to build a dark matter experiment. If you wanted to replicate this whole dilution refrigerator new, you'd be it'd probably be $500,000 just for the fridge itself, and all this wiring would probably add at least another $200,000. So this is roughly $700,000 piece of equipment, which is why we're putting in the effort to see if we can get it working. One of the nice things about this system, though, is you can see up here on the this whole top flange is where they do all the readout. You see that panel right there? It has a ton of SMA connectors, and everything goes into this top thing here. The top box is designed as an electromagnetic shield so that you can try to keep electromagnetic interference out of your lines. Also, probably overkill, but it is it's a very big and robust system, and it makes it a little harder to work on, but actually the top access is actually fairly elegant. Unfortunately, there's one thing missing from this fridge. They actually stripped out the low noise temp amplifiers. Which are about $7,000 each. So there are probably 20 of them in here at one point, but I guess we can't have all the good luck. So we'll have to figure those out later. Does this look like something that's gonna break your encryption on your bank account? Yeah, I didn't think so either. All right, so there's the mess we removed. Now we can get under here. Look at the clean plate where we've got where our experiment can mount. So that looks pretty good. I don't see any stuff that's going to cause a problem. We have our niobium tie coax. We have our Cooper nickel coax. Everything looks pretty much ready to be buttoned up. So we'll now put on the lower shield and start closing up. Oh man, it was recording. Missed all that content. All right, so we got this shield going on. I didn't think we should clean that one, yeah. I just use the white. Well, I use one of those towels, but it's mostly. I did clean this undersurface here.
Yeah, I was just gonna do that again too.
All right, cool. We're gonna have to take this off. Might just do that. Might just screw it. I'll probably tilt this sideways because this is O-ring surfaces on both sides there. So you have to actually be careful with this one. And clean those O-rings off when the time comes. Let's just be consistent and put the welds together. Just, I don't know where the weld bead is on this one. You see it? No. Let's just put it facing right for now. So this one is right here. So this one right here.
it every third unless you want to do more.
I was doing every other. All right, we're gonna go up. This one's got super insulation on it, so I've got to be a little more careful with it. Okay, so we got the super insulation. So the next one is O-rings.
Yeah.
Yeah, so these are gonna be the heavy ones. All right. So here's what we gotta do. We gotta lift this guy, just the top section, over here, put it up here, and then screw into these. So if two people can lift, or maybe three people lift, and one person screws. Yeah, how do those work? Okay, you want to be the third lifter?
What?
Yeah, I'll get three people in the lifting. Yeah, good. Yeah, the problem, and you can see that they had the problem too, is that you can't spot where to put the bolts in. So I'm gonna put this one.
I'm gonna switch to the bottom. I've switched to the bottom.
Yeah, I switched to the bottom.
Okay.
What's it?
Right, rotate right. No, rotate a little to the right.
Not to the right.
Okay, lower it. Let's see where we go. Okay. Yeah, so go straight up. This sucks. No. Move back one angle up and see a little better. Okay, I'll give you one.
Is that in?
Yeah, got one. Good. That's the hardest part now. Okay. Yes.
We finally found one that's not around.
Maybe. Okay. Sit. Whew. Yeah. It comes off like that.
This just hangs here. And then you pull one of these off and connect it to the ears.
Yeah, that makes sense.
But except again, the problem is you're gonna have the thing lifted a bit before you can get this on.
Well, we can put it on that base, right? I mean,
Yeah.
we could.
I don't know if that's even enough.
Okay.
But anyway.
I think we can get it just from here, Joe. I don't want to take too much of your time. All right. We'll get it going. Yeah. All right. So, how do you think this is going to work?
You need to lift it up like a foot and a half. Maybe put it on top of anything. I don't think.
You don't think we could just go, one of us lifts this and clips it on?
But then it's gonna be all wonky. I mean, sure. I guess that's right. Yeah, I think you're right. That probably works. Okay.
Right. Yeah. Okay. Going to the gym today. I didn't know. Yeah, you do have to slam that. It's quite a contraption we got here.
This is awesome.
Would this pass muster at
Production
LA?
lab.
Look, I mean, this thing is barely holding it. Let's not think about that too much. Yeah.
It's just gonna go up like butter.
Okay, I want to get a screwdriver ready. You got one?
I got one.
Okay. It's gonna go like butter, you say? Let's see how it goes. Oh my god. Oh, that's so easy. It actually worked.
It works.
Oh, wash your bottom out before it gets done. It needs to be. I can't believe how well that worked. I'm not going to talk bad about Martinez's engineering anymore. That actually worked shockingly well for how janky